In today's lesson, we'll be continuing section 6.1, but we'll be focusing in on multiplying and dividing rational expressions. It will be very similar to what we did yesterday. We're going to look at each of the numerator and the denominators and see if they will factor down. And once we do that, we'll use the properties of multiplication and division with fractions to cancel and reduce if possible. So if we take a look at number 1, in the first fraction, we have x minus 3 in the numerator and 5x in the denominator. Neither one of those can factor down, so we'll just rewrite them and keep them the same. But what you'll notice is that in the numerator of the second one, we can take out a 3. In the denominator of the second one, it's 4 terms, so we're going to split it. I'll take out an x squared, and we're left with x minus 3. And then we'll take out a 2. And then we'll regroup. So it's going to be x squared plus 2 and x minus 3. And if we remember about properties of multiplication with fractions, that really, when it's multiplication, this fraction bar just really extends right here. So from that point then, we can cancel out the x squared plus 2 with the x squared plus 2. And then we can also cancel out the x minus 3 with the x minus 3. And what you'll see that we have left is 3 over 5x, which cannot be simplified. In number 2, you'll notice it's a division problem, which will be very similar to what we did in number 1. The only exception is that when we're dividing by fractions, we should be multiplying by the reciprocal. But I'm still going to go through that same process of seeing if the numerator and the denominators will factor down. Again, the way that you choose to do your factoring process is up to you. I'll show you the first one with grouping, and then you can do the other 3. So I would do 8 times 3, which is 24, and I would find the factor pair that adds up to 14. So if I just list them on the side, you'll notice that 2 and 12 does the trick. So I'll rewrite it as 8z squared plus 12z plus 2z plus 3. I'll split it. I'll take out a 4z right here, and I'll get a 2z plus 3. I'll take out a 1 and left with 2z plus 3. And then I'll regroup and put it over in my numerator. 4z plus 1 and 2z plus 3. Now, I would basically do the same thing, or I could do guess and test for the other ones. For the first denominator, we get 5z minus 1 times 4z plus 1. Again, multiples of 20. That gives you 5 and 4. Multiples of 1, 1 and 1. And then you can check the inside. This will give you negative 4. This gives you positive 5. That adds up to be a positive 1z in the middle. I'll do the same thing with this numerator. I know the only combinations for 2 can be 2 and 1. I know that the combinations for 6 will be 1 and 6 and 2 and 3. And now I need to kind of decide which will give me 7. If I do 2 times 3, so 2 times 3, that's going to give me 6. And then if I put the 2 times 1, that gives me 8. That won't quite work, so I'll try something else. So I'll try the 2 here. That will give me 4. And then if I put the 3 there, that will give me 3. And that gives me that 7. And both of those are going to be positive to make it a positive 7. And then finally, I'm going to do the denominator, which gives us 5z minus 1 times the quantity 7z plus 2. So now I have this division I have to worry about. So what I'm just going to do with that is that everything after the division sign I'm going to flip. So we're multiplying by the reciprocal. That first fraction is going to stay the same. 4z plus 1 times 2z plus 3 over 5z minus 1 times 4z plus 1. And then again, we're going to multiply by the reciprocal. So I'm going to bring this 5z minus 1 to the numerator and the 7z plus 2 to the numerator. And then finally, the 2z plus 3 to the numerator and the z plus 2 to the denominator. And then I'll see what cancels. We'll notice that the 2z plus 3 cancels there. 4z plus 1 cancels there. And we also have the 5z minus 1 cancels there. And what we're left with is 7z, ran out of room, 7z plus 2 over z plus 2. We have 3 more problems like this, 2 division and 1 multiplication. So go ahead and pause the video and work on these 3 problems and then restart the video and see if you got it correctly and you factored correctly. For number 3, you should get negative 2y cubed over 5 times quantity y plus 1. Couple things to notice, that you don't have to distribute at the end. You can leave it in the factored format. That will make sure that you didn't forget to cancel anything. Also, I want to point out is right here, I took the y minus 1 minus y, and I took out a negative sign. And the reason I did that is because when we get to this part right here, it's 1 minus y, and they don't quite match up. But if I take out the negative sign, then they do. So that's going to be your final answer there. For number 4, you'll end up with negative 2x cubed. You can see that this is a sum of cubes right there, and those cancel out nicely. And then finally with number 5, we end up with 2 over the quantity 5 times quantity x plus 4. And again, you can see that I switched this around because it was dividing, and the problem cancels out nicely. And finally, our last problem for the day, we have a word problem that says a company's cost per book for printing X books is given by the rational function. The cost of X equals 0.8X plus 5,000 over X. And we just want to find the cost per book for printing. So again, it's asking for 100 books, and X is the number of books. So all we're going to do is we're going to take 100 and plug it in there. So the cost will be equal to 0.8 times 100 plus 5,000 over 100. When you go ahead and evaluate that, that's 50.80. And then the second one asks us to find the cost at 1,000 books. And again, X is 1,000, so we're going to put that in for 1,000. And when we simplify that, that is 5.80. So $5.80.